think we're good here. Let me just set up a couple things. Let's see. Good here. Let me just set up. Set that, and I'm also gonna put the GitHub link too. I'll close that. Seems like the audio's good. Let me just check the microphone that we're using here. Okay, right, microphone, okay. Put the chat. All right. Seems to be good. Let me just bring up Paint because we're most likely gonna need it today. Most likely. Yeah, so we can just have Paint here just in case. Give me a couple more minutes and then we'll start. Okay, everything's here. All right, yeah, it seems like we are ready to go ahead with this. As we know, last time we did actually finish the lecture, and we can actually test it out and see right now. I can show you how the lecture is doing things. So we have int, if we write like int x equals 3, the lecture is able to accurately identify the tokens, the proper tokens that we have. So that's so far what we got. And we can also, this is for the REPL, but we can also do that for a file as well. So, I mean, let's just say like if x is equal to 3, right, it'll give us the correct tokens, right? That's for a REPL, and we can also do it in a file version as well. Let me just grab that thing here and correctly do that. Yeah, so this is just a test file that we have. It's this file right here. This is just to test the test cases that we have. I haven't wrote like a manual test suite thing. I might do that at some point though. Yo, what's up, Ghost at HX? How you doing, bro? But yeah, so we have our regular cases, so it just basically covers everything that we have for our language so far for the compiler. And we have 2 bad cases here, so this is illegal. We can't have this in the language, and we can't have an unterminated string, so it gives 2 errors for those 2. And everything else seems to be working perfectly. I like triple checked this before, so that's what we left off on last time. Today we actually need to make the grammar rules properly. I'm doing good, Ghost. I'm excited to get the parser written. I assume it won't be easy though. But yeah, we need to get the grammar rule, so the parser. So let's say we have like int equals 3. This is illegal. We can't do that. But the lecturer doesn't know that yet. The lecturer doesn't know that it's a rule not to have that. So we need to actually create the grammar rules for the specific compiler. So that's what we're trying to do. It's not going to be done in one day. It might take 3-4 streams, but we'll see. So yeah, that's basically what we got to do for today's part. Hey, what's up, Char? When did you start learning C++? I've been considering giving it a shot. Just a couple months ago. I started in March, probably in March. Sometime in the middle of March, I decided to just start. And I kind of just threw myself in a project on my risc-v emulator project. It was a difficult project, but I just threw myself in it and said, you know what, let's just go through it. We'll get better at programming if we just do hard projects. Parsers are not that hard. Make the keywords like int, if, etc., and a var. If a var name, then error. Yeah, I was thinking. So I've been researching for the past couple of days. So I was thinking of doing like a mix of parsing and recursive descent parsing for the parser. But before we start that, I just want to. Some people gave me like some recommendations to optimize it a bit better. So I'm just gonna do a little optimization here. It's not really anything special, but let me just do that real quick. Just for a couple of these. I think some people had some things to say. Yeah, someone recommended I had this earlier as C is less than colon, I think. I had to change it to less than or equal to 9 to display intent properly, and I think that's pretty much the only two suggestions I really got. Someone said make these const expr to make the compile time evaluated, and also no except. Basically, you're telling the compiler like a guarantee that you're not going to have this function throw exceptions. I believe. I don't know what the optimization of the no except is. Like, I don't think it really optimizes anything specifically. I'm not sure though, but I know this is a pretty decent optimization with const expr. I think that's it. I think that's the only things I got as a suggestion, but any suggestions I will always take if you guys have anything. But yeah, we need to start the parser now. We can start that. So yeah, we need to make. Okay, so I'm thinking of splitting it up like this. So we need to have our abstract syntax tree, setting up the basic for that, the structs and everything. So we need to have let's have like a ASD header file. We also need to do, of course, we need our parser cpp parser h files. You're very good at C++. And not really. I'm just I recently started. I have so much to learn. I'm just willing to take any recommendations and any advice, and whenever someone gives me a piece of advice, I make sure to look it up and actually know what and when to use it. But I still have a lot to learn. The hard part is the if, else, while, for. Yeah, I'm not looking forward to that part. Well, I am looking forward to it, but it's just gonna be hard. So let's just start making some files here. Oh yeah, we also need to do the visitor pattern as well. Okay, let's just start making some files here. Let's just add some files. Oh, I don't want it to be here. I want it to be in the compiler, but okay, I'll just move it upwards. So let's say ast.h. I'm just gonna move it up here into the source of the compiler. let's just make our generic files here. Let's call it visitor.h, parser.cpp. We also want our parser.h. So yeah, so we have our files made now. So I do have some notes, basic notes that I have just to guide myself as I write. So hopefully I don't mess up too much, but we'll see. Yeah, so this is probably the plan. Let's just write out like a little agenda plan for today. Right, so we need to make different node types. So I'm thinking of having an expression node. So any type of expression. So expression nodes can be like, let's think, like 4 plus 5 times 2. Basically for the initial expressions that we have. We want, and then also splitting it up, not literal, statement nodes. So since this is very heavily relied on precedence, this is where parsing would be really helpful, and this is where recursive descent parsing would work for statement nodes. Statement nodes would be anything like if statement, while, return statement, stuff like that. And this is where recursive descent parsing would be perfect, since we're not relying on precedence rules to make that. To AST, I do not know if you know this, the parser makes the tokens into a function like token type print, token type left parentheses, token type body, token type right parentheses. What do you mean by that exactly? Because I know in our lecture header file, this is where like I defined all our separate keywords that will be the tokens that we'll be referencing. Oh, okay, I see what you mean. Yeah, return node prints in the function. Yeah, I see. Statement nodes. So these two type of nodes we need to actually make in the AST. In our visitor.h, we need to make the visitor pattern. So essentially allowing functions, essentially allowing functions to be implemented for each node type without having to specifically implement every single function within every single node. I think that's all we'll probably get to today, but we'll keep going as we go. So let's kind of start coding it now. So the ast.h, so we need to start with the expression nodes here. So yeah, expression nodes are anything like our separate expressions that we have. And there can be many different types of expressions. So I'm gonna kind of just make some space here. So there's many different types of expressions that we can have. We can have binary expressions, which binary expressions are basically like 4 plus 5, stuff like that. X equal y, stuff like that, where there's two operands that are being operated on from the operator. We need to implement unary expressions, and this will be anything like our not x or -5, stuff like that. I guess also our identifiers as well. Identifiers would also, I believe, fall into this range here. yeah, so I guess we can kind of start. So there's many different types, right? So we need to basically have a base class that basically sets up the expression, and then every derived class will implement that further. So let's just start with our includes. Include. We'll probably, I don't know if we're using iostream, but maybe just in case iostream, we'll definitely be using string. I see you retracted a message there, Ghost. You were probably explaining something. We'll see as we go. All right, so let's kind of see. Right, so we have not our class. Let's make a struct. So struct expression, and yeah, expression is fine. So we're taking a struct expression, and we're basically setting up this base class. So let's probably do like a virtual function here. So we could probably do like a virtual destructor right here. So it makes calling delete safer. And we want to set that to default. So default destructor right here, or expression. Actually, yeah. Let's make it like easier to type expert. And now every single struct will be inheriting from this. A way to make compiling faster is making data types i32, i64, i128. So like the specific kind of like the std, what was it called, like std int h header file where they have like fixed size, fixed width integers. Is that what you're talking about? Or is that something completely different that you're talking about there? It is, okay. And I guess that would probably be implemented more in the back end. So my CPU emulator I have here, I only have support for floats and ints so far, 32-bit floats and integers. So maybe I might do 64-bit double, like the double extension for 64-bit at some point, but yeah, for now we don't have that yet. Okay, so every single struct is going to be inheriting from this. So let's make a new struct, and let's call it like binary op node. And we want to inherit from expert. And let's kind of think through what exactly do we need. So this is where probably paint would come in handy. Alright, so binary op node, we'll have something like, let's say like 4 times. So like 4 plus 5 times 2. Where did it go? Oh, okay, there it is. Okay, so essentially we're going to have our operator here, and we'll be having 2 nodes to the left and the right. Okay, I did the wrong direction for when I said left and right, but yeah, left and right. So we'll have basically 2 directions that we go, and this is like the base of the tree. So we'd have like, I can't draw it, but yeah. Okay, so kind of like this, where we have this pointing to 2, which is our right node, and we have, I guess it would be the plus inside of it, which then would point to the 5 here. So this is how like the abstract syntax tree would mostly look like for that. And this could be anything. This could be a literal value. This could be a function call. It could be I mean, it can just be like operator itself. So that's why we need to actually have the base expression and have everything inherit from that, so it can actually be evaluated later what the actual nodes would be. And I do tend to see in most compilers that there's like two implementations I've seen. I've seen shared pointers and I've seen unique pointers. I might use unique pointer for this implementation. So I guess like, okay, so we're gonna need like 3 separate variables for our left node, right node, and operator. I'm also gonna write some comments here, give some example. So like a plus b, a times b, a equal b, and I think they get the gist of that. Okay, so so you have 2 nodes and an operator. I mean, I believe that the operator itself would just be a specific token. We'd know what the operator is, as opposed to the left and right nodes, which we don't know exactly what it would be, I guess. So I guess we can call we can write like, okay, we need to include the memory header for that though, to use that. So we want to call stud unique pointer. That'll be a unique pointer of expression. So whichever value the left node would take, it would be taking from an expression, which we know. And we can just call it like left. Well, even my notes, that's how I also like kind of said it. I wrote like all the types here just in case I forget like how the different types are. Yeah. Okay, so set a unique pointer to the left node and also a unique pointer to the right node. I8 equals char, I8 pointer equals string, etc. Yeah, I see what you mean. And a tip in ASC.h, just hold the final tokens like print, input, etc. And in the parser make the function that AST is just for the nodes. Yeah, the AST is just for the nodes. Parsers where the actual logic is going to be implemented, which I don't know if we'll get to on the stream today, but we're kind of just setting up each expression here today. It depends on how quickly I get this done, how quickly I can reason things out. Okay, so, we don't need a unique pointer for the operator. We can just call token. We can just call a token in general and just say that's the literal value. So we can just say like token and call it like let's include our thing. So we can kind of say like, what's wrong with this? Well, let's just insert some token operator. Okay. Yeah, looks like that. Everyone away? Okay, so this is basically our binary op node. We're gonna do the same for a couple of other ones. So struct unary op node, which we'll inherit from expert. So unary op node would just be like, we'll say for example like not x, not negative x, etc. So this is basically, it's going to be a different format. So it's basically just going to be, you're gonna have the operator again, but we're going to have the operator be on an operand value. So, I mean, I guess just, we wouldn't know exactly what the operator is, so I guess we could call that as the unique pointer of expression again, and call that, let's say like operand. When you get your language done, I want to try, and what is the name? I actually don't know what the name is, to be honest. I haven't thought of it. I have to think about the... When you get your language done, I want to try it. Yeah, I'll let anyone try it. It's gonna be a long time though before it gets done. And we're just doing basic language right now. I'll probably add more stuff to it later, because this is my first time writing it, so I don't want to make it too complicated from the get-go. It's already complicated enough as it is, to be honest. And yeah, I need to come up with a name. What other types were there? I believe literal nodes as well. So literal node, and heard from expert. I can't type right now. Literal nodes would just be like our literal value, I guess, right? So like it can be anything, like, I don't know, 9090, 3.14, hello world, like literally any literal value, etc. So, I mean, we don't necessarily need we don't need a unique pointer here. I'd assume like the literal value is already going to be made. We do have literal, which is specifically for our literal values in our Lexer struct. So I'd assume probably just, let's see if that's even possible. Can we do that? Literal. Yeah, we can do that. So that would just be the value of itself, the value of the token itself that we receive. You got a name if you want, V++. There's a language called V and it compiles it. It compiles C, so V++ can be the better version of V. Maybe that's a good idea. And also, I guess, for my risc-v, the risc-v emulator, risc-v allows for vector instructions, which is a completely different paradigm. Vector instructions, which basically allows a bunch of instructions to be executed at once. So it's kind of like parallel processing in a way. I have to look into that though. I haven't looked into it, but it is something that risc-v CPUs can do. But it looks very difficult to implement. But maybe that's a thing we can do at some point, and add that to the compiler as well. And I guess the V in risc-v stands for vector, so V++ would be a good name. I guess it kind of works out like that. Language is gonna be faster than Rust. Didn't Rust take like 10 or 15 years to develop? If I want to make it better or faster than Rust, I'd have to be developing it for a long time. I just have to focus right now on not making it a shitty compiler. Because I don't know if it's going to be a shitty compiler or not. It could be one. But if it is, I'll just try and make it better. But yeah, let's keep moving on. Let's keep moving forward. little nodes, identifier nodes. Yeah. Okay, so identifier nodes. Yeah, but you can use LLVM API, very easy to use. Yeah, I'm going to be using LLVM after I implement my own backend first. I want to try implementing the backend just for practice, just to understand how backends work for compilers. Then I'll probably move to LLVM if I deem it fit, because I know it's going to be super slow if I make my own one, but I just want to try it just for the practice. But yeah, LLVM is the industry standard to use, so I'll probably end up using that anyways at some point. Alright, so identifier nodes, I guess the identifier is just gonna be like I mean, I guess it's just the literal again, right? Oh wait, it's not the literal. I guess it'd be the type, right? It would be the type. It'd probably be the type value. Well, not really. Token type is like the actual token itself, so I guess we can just call it token and just call it like name. I was mixing it up in my head. Identifier is like the name, not the type. Sorry, that's different. I was mixing up in my head for a second. The linking is very hard to do when you compile. Yeah, linking is a separate process, I believe. Completely different process. I believe when you compile, it makes an object file, and then the linker links those object files. Make all variables constant. Okay. Oh yeah. Let me write like what's like an example of an identifier? I mean, I'll probably just write like yeah. Okay. What else is there? What do you mean by make all variables constant? Like, what do you mean by that exactly? Like, in which part? Okay, yeah, variable name is just token. We don't need any unique pointers there. Struct, I believe there's one more. Function call nodes, yeah, function calls. So I'll call it like func call node. Inherit from expert. And okay, let's think of a function call. That's a bit more stuff there. So function call usually has like yeah, so you have like the function that you're calling, and then you're passing in like an array of arguments, I guess, just like any amount of arguments they give. So like arg1, arg2, it's up to the programmer to decide how many arguments they put. So I guess it's dynamically sized then, right? So right, and we don't know what exactly the arguments they will pass in will be, right? So let me just put this in, let me put this in the beginning. For compiling in your language, if you make variables constant by default, vars constant by default, it'll make it faster. Like, do you mean in here, like cons or something? I believe. Or do you mean like the function, or? Because I don't know if we can make these constant, right? Aren't these values going to be changing? Or do you mean something else? Okay, func call node. So, okay. So I guess the function name is one thing, right? Function name is one thing, and then the different arguments that we have. So do you think the left and right parentheses would count in that? Or is that just like a thing? Oh, when I parse vars. Okay, yeah, I understand what you mean. Sorry about that. I didn't understand for a second. And make the mute keyword to make a var not constant. Is that what Rust does? I believe I've seen some syntax like that, like let mute something, I don't know. I feel like I've seen that syntax in Rust before. Okay, function calls. So I know for a fact we need a vector, because this can be dynamically sized in any way for any amount of arguments. So a vector of the arguments, and for this, the function name. I guess this is the just the function name. I guess we can just call that like a unique pointer for that. So unique pointer. So we're gonna call that like name. And then we want it's a vector. I need to include vector at the top. So include vector. Streams, audio's fine, right? Okay, yeah, everything's good. Yeah, so it's vector down here, and I guess we're passing in a bunch of unique pointers for these individual expressions, I believe. Can you do that? Are you able to do that? Like, let me see if it's possible. Just a unique pointer expression. And just have that like that. And wait, so okay, you can. So the name would go after here. Not name. Works. Okay, looks like that works actually. Okay. So you can have a vector of a bunch of unique pointers to the arguments. Int x equals 10 to make it not const. Mute int x10. Okay. That's interesting. Wait, so is that like in Rust? Like in Rust, you can actually make things not const after you. Okay, so the variables in Rust like always constant, and if you use mute, it turns it to not const, or what? Okay, what next now? So we have, I think this is all the expression nodes that we have, right? So these are all the expression nodes. So these basically act on any individual expression that we have, but now we need actual like statements. So if statements, while loops, any other type of statements, return statements, stuff like that. So we want to make a different type. So this is gonna be for parsing later, and this will be for recursive descent parsing afterwards. So I'll probably write like a comment. Parsing, because these work on precedence and stuff. So, and then something like recursive descent. I wish I could type right now, but recursive descent. In Rust, to make a variable not const, you use mute like let mute x equals 10. If I do not do that, I cannot make the value anything else. Okay, that's interesting. So I guess variables in Rust are constant by default. I'm gonna learn Rust at some point. The main thing is between Rust or Zig in my future endeavors, which I'll have to look into the pros and cons of both Rust and Zig, and then decide which one I'll go to. I mean, you guys can convince me to go one path or not, depending on what you say. Okay, so for this one, it's gonna be our statement nodes now. So we need specific nodes for each type of statement that we have. And these are the specific ones here. So variable declaration, return statement, if statements, while loops, blocks, and expressions. And the reason I'm not doing for loops, I was kind of like doing some research into for loops, and apparently for loops is just a different type of implementation, a very similar implementation to while loop. It's like a while loop under the hood or something. I saw somewhere something like that. I need to look into it more. But for now, we'll just do the while loop. So yeah, so basically the same as earlier that we did. I can help with Rust, not C++. Start with Rust. The memory management is way better than Zig. In Zig, you have to do it manually. Interesting, okay. So like, how do you know how memory works in Rust if you don't have to manage it at all? Do they teach you that? Like, are you able to do manual at all, or does it not let you even do manual? Okay, just like how we had here, struct expression, this time we're gonna make it, struct for, I'm forgetting the term, struct for statement, yeah, statement. Yeah, so we'll call it, let's probably call it like this, so it can be smaller. Struct for statement, and we'll make the virtual for that, so virtual statement, and make that a default destructor. Yeah, so that should essentially be that, and then we can now have some derived classes that inherit from the statement. So different types of statements that we have. Let's start with variable declaration first. So I'll call it for statement or something like that. That seems kind of long, but it's fine. And we want to inherit from statement this time. In Rust you can do by hand, but you do not need to do it. It's like a GC, but not. Think of Rust like C++, yeah. Yeah, I wanted to learn Rust, but I just ended up learning C++. I'm still learning C++, but I just ended up picking up C++ first. Just for the future, like getting a job and stuff. I still feel like C++ is more of an industry standard, at least for a bit longer. Maybe for a couple years, maybe even a decade or two, maybe. Who knows when the adoption standards will change. Only time can tell, I guess, about that. But yeah, my plan is to learn Rust, or maybe sometime in the future. Maybe next year. Okay, so we have a variable declaration statement. So how are variable declarations exactly made? It's like variable declarations are kind of like int x, like stuff like int x equals 3. Yo, what's up, KZ Mans? I'm doing good, bro. Just writing out this stuff right now. If you want, I can teach you Rust. Yeah, you could. I'm willing to learn. Probably not now, but maybe later. I might reach out at some point if I need some help. Because I'm still learning C++. I don't want to take up another language right now. Okay, so that's how like a variable declaration statement might go. So Okay, so we kind of broke it down earlier into expression, right? So this would kind of be like our expression. I think maybe it's better to call it expression here, so people know that we can actually just use one of the expressions from here. So let's think of like the components of it, right? So first of all, we can also do like the identifier though, right? The identifier can also be one of the expressions that we had. But I guess, okay, this doesn't really matter though for the most part, I guess. So this can be resolved with the expression later. So I guess it's just this and this that actually matters to put together. So I guess we can call it like, for this we can say like token name, and we can probably say the actual initializer. So we can say maybe like third unique pointer. We'll still be inheriting from, we'll still be taking the unique pointer of towards the expression though. When do you learn CPP? Casey Mans, I learned it like in March. I'm still learning, but I just learned like the basics to actually start building stuff. And I'm using Learn CPP to learn more nuances of it. That's basically how I'm doing it. Okay, so token name will be that, but the unique pointer should still point to the expression where it actually initializes it. So we can call it probably like, I might be thinking of it wrong, but maybe like initializer, probably something like that. And next, what else is there? Yeah, return statements. Let's do a return statement. So statement, and we'll say it inherits from statement. And return statements are basically just like return x. Well, okay, I can't write it like that. Yeah, let me do the comments. Return x. So we have the return keyword and then the value. So returns a keyword. So I mean, I guess we only really need a unique pointer to the expression itself, just like how we did up here, just a unique pointer to the expression itself. So this is going to be like the expression here. We gave the token name for this just to get the variable name, but for here we don't have a variable name, so we can just call unique pointer expression and set that towards and call it like what should we call it for this one? Like return statement, I guess. Yeah, I guess just we'll call it like that or something. Red. Yeah, red's fine. I think red's fine by its own. Yeah, you're right about that, Ghost. Struct. Setting up these structs is taking way longer than I thought, not gonna lie. Or maybe I'm just dilly-dallying too much. I don't know. Okay. If statement. So if statement is writing a C compiler low-level embedded. I'd assume so. You are going to be using a lot of low-level concepts. Like when you get to the back end, you're going to be like basically translating the assembly for a specific computer architecture standard that you're using. So x86, risc-v, arm or whatever you're actually making it based on. But probably not so much the front end. Probably front end is probably not too low level. Okay, so alright, if statement, the components of if statement. So you basically have like if condition, right? Condition, I don't know, like equal. I mean, not condition equal. So just the condition itself. So you'd have like if x is equal y or something like that, anything like that. So yeah, it's not embedded systems. I think the guy was asking like if it uses low-level concepts, like the other embedded word. If that's even a thing, I don't know if I'm thinking of that right. But yeah, it's not embedded systems. Embedded systems is more like components inside of your stuff you're using. So like maybe an example would be like inside a TV. The components inside of a TV, that would be like embedded systems, or components inside of a microwave or something. That's what I believe embedded would be. Okay, okay, if statement. Alright, so if condition, I guess the condition itself, well, the condition itself would be something like x equal y or something like that. And that would just be, that would be an expression itself. That would just be a binary expression, I believe. So we can just call that the expression itself. And we can specify a binary expression right here. Well, actually, it's not always a binary expression. It can also be like if not expert, like it could also be a unary. So I guess it can just be any expression in general. So we can just say like stood unique pointer, point that towards expression and just call it like condition. I believe that would be good for that. Should you make a coding language, Ghost? Yeah, if you want to. You seem to know quite a bit about it. At least like the concept of it, so I guess you can write one. You should probably write one in Rust, if you know. Okay, this seems way too simple for... Are we saying... Okay, are we saying like the whole like if expression, like even the body of it too? Or just like that? Wait, so okay, so we have if, but we can also have like the body, right? But we can also have, okay, wait, the comments aren't going, but you can have the body, but we can also have like else. We can have the else like stuff. So I guess we also need to include that, right? So not trying to sound like an AI bro, but how do you guys feel about AI code and low-level coding? I feel like it's more difficult for AI to actually implement stuff for low-level code, because you need to be very, very precise for that stuff. And if you don't know anything about it, you're not going to be able to debug whatever slop it produces. Or maybe it could be good code, but you don't know it because you don't actually know the concept. So I think it's more safer in that aspect. I made a Lex for Parser, but then I lost the funny. Okay, so you basically made the front end of it. I mean, you can add on to that, just make a back end for that. The back end's gonna be way more difficult, because now you're actually making the actual language itself work behind the assembly code. Guys, you can teach me C++, please help. You can use Learn CPP or YouTube. Also, Hobby, I'm not going to be using too much AI here because I don't see a point in it if I'm just trying to learn right now. Maybe I will later if like I actually know everything about it, and then if I want to implement some new features that I already know how to do, I can use AI and then debug that code to see if it's good. But right now I'm just learning. And especially if I try to get like a compiler role, I have to actually know what's going on. I can't just have AI do it for me. But I can ask like for design choices though. Like here I'm kind of confused on whether we include just the if part, or do we also include the body and the else statement. So I might ask it that, to be honest. I wouldn't mind asking it that though. I'll only use AI like if I get really confused and I don't know what to do. If I don't know where to move on. So, okay, for context, I guess I'll just give it all of it. And I'll kind of just tell it here, right? So for my if statement, implement all of the statement, like body, if condition, else part, etc. Let's see. Oh yeah, you have to make sure don't. What do most compilers do for that? If statement should hold everything that makes up a complete if statement. Okay, the condition, yeah, so it has the condition itself that we have, so if expr. The branch is the body. Okay. Else branch is optional, the keyword being optional. Okay, so maybe a null pointer there for that value because it's optional. Else if is just else and if combined together, I believe, under the hood. Okay. Yeah, I totally forgot about that block part, the branch part. So we can say condition still, but we can say a new unique pointer. Okay, but it wouldn't be. It would be more towards a statement because the block is like a bunch of expressions put together. So it'd probably be not inheriting. It'd be a unique pointer to a statement. And we can call that, we can call the branch like they said. And unique pointer. I guess the else is gonna be an expression one, or else is, there's no condition for else, so it's just gonna be the body of it. So yeah, we don't need a condition for else. If expression body else optional. So possibly like the statement itself and call it like, what should I call it? I have trouble with naming conventions a lot. What to name stuff. You want to make the parsing as easy as possible. Yeah, that makes sense. That makes sense. Yeah, 5K is not that much. It might seem like a lot for like just one coding session or one person, but most code bases are probably hundreds and thousands of lines. Yeah, the coding language would definitely be more than 10K. I think, let me look at the interpreter itself. Not the interpreter, the CPU emulator itself. I mean, just here we have like 1,000 itself. Header file shouldn't be that much, probably like 100 something, 100. Main, probably not that much, maybe 150, 200. Yeah. Probably this, yeah, it's probably upwards of 2K maybe. And decoder's probably gonna be long too. Yeah, like it's upwards of 2.2K or something like that for my CPU emulator actually writing that. So I assume the compiler's gonna be way longer because the compiler is way more difficult than a CPU emulator. Okay, statement. Dude, what's the naming? I guess just the else. I'll call it else branch. Okay. We actually have quite a lot of people in here, so feel free to join the Discord, guys. I'll post the link again for the Discord. If I can copy this message here, I'll pin the message. Discord's right there. You guys can join if you want to. You can give me any recommendations for the compiler or any other project I have. Okay, I think that's it. Condition, we covered condition, branch, else branch. While loop, okay. Okay, for while loop, it's gonna be quite interesting. Python is 1.3 million lines. Dang, 1.3 million lines. That's a lot. I mean, it makes sense though. I guess that makes sense because Python has like a lot of functionality. I hope I don't get burnt out with this project, to be honest. Hopefully I don't. Because it is a big project. Not if. So while condition. And what is Python written in again? I think, is Python written in C or C++? So it's gonna be a while condition. So while condition, and then you have the body. Right, so it's gonna be very similar. So we probably have like a std pointer, and I'm gonna call this expression. We're gonna have a std unique pointer. To the expression itself, and we're gonna call that. Also, let's just call it condition. And we're also gonna need a body. We don't need an else branch. Also, I'm gonna probably right here could be null pointer. I mean, technically, couldn't this also be a null pointer though? If they don't write anything. Is that even possible? Can you just have a if branch without anything in it? Like, I don't know, I'll just probably write something. I'll probably try it out later or something. Is this a uni project? No, it's not a uni project. This is just my own personal project. Uni's not doing anything for me, to be honest. Literally the only thing Uni's giving me is just like the degree at the end. That's literally it. But the classes are so unstructured. Well, they are structured, but it's just so slow. Not teaching well. Still either. So it's up to us to learn it by ourselves. Whatever we want to go in. What major? Information technology. And I might do a master's in CS. Just if I don't get a job by then, I'll probably do a master's in CS. but I'm hoping I can probably get one by then. Which uni? It's just like a random state college. Okay. Let me think. So statement. So the statement's just gonna be, yeah. So just call it like the body. So I guess, yeah. Is there anything else for well, nothing really, right? Yeah, not really. Why not CS or something similar? Yeah, I probably should have, but I was gonna graduate a year early if I did information technology, and I didn't really think that the degree itself really matters, because you can end up with a software engineering job with any related field, like math, physics, information technology, and they still teach like a lot of stuff in information technology. So let's hope I didn't make a bad decision, but I think it should be fine. I don't think it really matters, to be honest. So struct for block statements now. Let's try and do that. So block statement would just be something like this when you have something in between two of these braces, and you just have just random stuff, whatever's in there, body or something. That's literally it. That's literally it for a block statement. So we'll call it std block statement. Inherits from statement. We'll say std unique pointer to well, I guess it would be statement here. It's not really a single expression. A block statement can be comprised of a bunch of different expressions, which is what a statement could be. So I guess we need to have a unique pointer be of a statement, and we'll call it like or something. I mean, reading 5,000 lines of code is still a lot. Yeah. I mean, probably reading like you're probably not reading 5,000 lines at a given point, like at a single time. I'd say probably if you're doing a job, you'd probably be reading like a pull request from someone else. Probably reading maybe a couple hundred lines of code someone wrote on a pull request. Maybe it might take like an hour or so. That's probably how it would be in most cases. Yeah, I think that's good for that. Well, that's a single unique pointer though. We don't actually know how long the body will be that they put. And I believe that this statement will become from the block statement for that body part. So I'm thinking, should I use a vector here or not? Should I use a vector here? Because we don't know the amount of statements someone would give. A block statement can be comprised of any amount of separate statements. So maybe, just like how we did before with like the amount of arguments, that was kind of arbitrary. We don't know how many arguments they're gonna give, so I guess we can also do the same thing there. So call it like a std vector of statements, of unique pointer statements. So the unique pointer. Oh, yeah. That's why. I mean, I guess, right? I guess that's right. I'm trying to think. What else is there? Expression statements. Expression statements would just be like, just an individual expression, right? So it's like literally just the expression itself. So isn't it just gonna be, isn't it just gonna be a unique pointer to the statement? Just a unique pointer to the expression, I mean, sorry. And just call it like extra. I think, right? I mean, I think this is good. I think this is a good set. So let's just go through it again, right? So we have the ones for parsing where precedence matters. So we have an expression, individual expression. So we have a binary expression which has an operator and two operands that is operating on. You have a unary op node, which is just one operator that's operating on an operand. Any literal values that we have, so any of these values that it could be, identifiers for variable names, functions and their arguments, and now here for the individual statements, we're using recursive descent parsing later on. Variable declaration, an expression, it's a return statement, if statements, while loops, block statements, and then regular expressions here. So yeah, I think that's it. I think that covers it. I think it should. So the next part would probably be the visitor pattern that we need to do. So we can actually tell these AST nodes what to actually be doing. Because we don't want to implement functions for each node type like that every single time we create a node. So that's why we need the visitor pattern here. So let's say I know we're gonna need our AST.h for sure. And to be honest, we didn't need IOStream at all. We never used that. We never really used string either. So I think that should be good for that. And now for the visitor pattern. We're not using IOStream here either, so I mean, I guess just, I don't know yet. We'll see as we go. I just know for sure we're including the AST.h since we need to reference those different values. Okay, let me read upon this again real quick. So what exactly we need? So we need the base visitor interface here. So essentially for each method in the abstract syntax tree, the nodes, we need to set up a visitor function for those. Then we have the node classes themselves will have a separate function, the accept function. And that will basically give it the implementation, kind of like the behavior of it. So depending on what operation we're actually doing, that's what the except function will basically solve. Okay. Yo, what's up, EXO? How you doing, bro? Music will drop in summer and the cartoon will also release in the summer. Song released first in the cartoon. Please note the song will only happen once. EXO, bro. I feel like you're jumping with too many things, bro. I mean, I get that you're young, EXO, but you gotta find some niche and stick to it. Because, like, when you're making your games, you kept jumping between game ideas and you dropped every game. But yeah, if you like to do the music stuff, cartoon stuff, I guess do it, but stick with it though. Try and stick with it for at least a while, at least a couple months before you pivot to something else. Like for example, your games, you did it for like 1 week or 2 weeks and then you pivoted to a different game style and stuff, so. Yo, what's up, Street? How you doing, bro? Okay. Just give me a little bit more time to actually kind of refresh my brain on what the visitor exactly is actually doing. Okay, so we're setting a new binary op node, and then the functionality for it that we're taking, but we can't actually make this right now for our the current way that we're doing it. That's why we need to have an except function, and then we need to set up visitors for each function. Like that. So I guess you could say like struct. Oops. You could say like struct. We'll have like different visitors, so we'll call this one like expression visitor. I think that's probably the best way to do it. Just call it like struct expression visitor. And we also most likely want... Damn, finally found someone who will code in the background when I code. I hope it's not too distracting for you though, because I talk a lot when I code, so it might distract you when you code. Wait, EXO, what do you mean by studio? Do you actually have like a studio, or I thought like you were just developing in your house? Let me kind of map it out. So we're going to need separate functions for each one. So we'll probably have something like probably like visit like binary op. And we'll make functions for each one. So visit binary op, like visit unary op, etc. And we'll have to make those functions. So I guess they will be having the same pattern of virtual. We first need a virtual destructor for each function here. So what should we call? I guess it's a struct name. So visitor, just like before. Default. And we'll have separate virtual functions for these. Virtual, just like how I said, it's a binary op. And we're going to be passing in the value of the binary operation that we're doing. Like this would be this first initialization value that we're having. So we're going to need to be passing in a binary value, the binary opnode value. So it's called binary opnode, right? Yeah, binary opnode. Opnode. And we don't want to create it every time. Let's make a reference to it. Let's call it n for node, I guess. And I guess you just set that to 0. My question is, do we make it const or maybe not? No, since we're wait. Yeah, probably not. Since the state of that can change anytime. Nah, not to worry, I'm actually kind of new to this. Got into CS engineering in university, now I gotta take this seriously. Yeah, you gotta just find some niche to go into. You're CS engineering, so you might be doing more low-level stuff like computer architecture, operating systems. You'd probably be doing even like embedded systems or something if you want. There's a bunch of fields you could try. I mean, EXO, if you're still interested in making games, you still can. You just have to learn how to actually make the games properly and then market them properly. I believe this is how you do it. But I'm not exactly sure. I might check with Claude just to see if I'm actually doing it right. So, am I doing this part correctly? To set up the visitor pattern. I will also be implementing, what is it, accept function, right? Yeah, accept function. Accept function, so don't complain that I don't have it. Oftentimes Claude wants to finish off the code and just give me the entire function, so let's make sure it doesn't do that. I believe this is the way that most compilers do it though, how they do the visitor pattern. They set it like this. They set some virtual functions for that. Think about the return type. You have void on visit binary op. So I'm also coding. What's up, Kato? How you doing? I would code, but too late for that. It's like about 12 a.m. here. I like coding at night better. What's your niche? I'm just doing compilers right now. Compilers, and also I did make a computer architecture project that links directly with the compiler, so I'm trying to see where that goes. Hopefully it works out well. But yeah, compilers I guess would be the niche, like the direct niche for me. Okay, wait. When your IR generator visits binary opnode, and needs something to get something back, like a virtual register number. Yeah, I know. I'm gonna get every node type. I know, Claude. I know. Making them prove virtual is correct. That forces any concrete visitor to implement every case. Yeah. Okay. Return type. Best of luck on that. I appreciate it, Street. I appreciate it. Because after visiting the node, I mean, I guess it's just making that new. It's just making that new binary opnode. I would assume that is just making primary node, and we would implement the specifics in I would, but I'm not meant to be up. That makes sense, that makes sense. What time is it over there, Ghost? Yeah, so I'll make roles on my Discord and stuff like that. I just have to get to it. I just made the Discord, like, I made it a long time ago, but I never invited anyone to it, so I just invited people today. Discord is in the pinned message in the chat right now, in the live chat. Oh, so almost same time. My sleep schedule is so bad right now, to be honest. Prior to the visitor itself is just interface, specifics living the concrete implementations later, but think about data flow. This is the visitor returns int, representing the virtual register index. Oh, is that actually the case? I actually didn't know. Sam, we go to bed at 4 a.m. every night. Dude, that's so real though. It's bad, but like, I gotta fix it. It's bad, but it's like so satisfying though to stay up like late. Cause it's just like your alone time and just, you get to just basically watch YouTube or just chill. But it wastes so much time though, which is the problem. I might look this up for visitor patterns in compilers. What do virtual functions return? Virtual return a result based on the type of element being visited that corresponds to the operation being performed in the element. Let me take a look. I might be the visitor pattern. Okay, so I mean, people are doing void. This is why I kind of wish I had more C++ knowledge. This is, at times like this is where I kind of get confused. Call the function accept. Yeah, so you have your accept is gonna be implemented down here to actually set the implementation for each one in any way that you need. But I don't know. I might copy this, ask Claude like why this scenario they can use void. Explain me further. Once I understand that concept, we can actually do it properly. Yeah, no, I understand the mechanism of it, but yeah, I understand the mechanism. I just need to know why void is here and then why we can't have void. Modding something like a printer and bit of a counter, a side effect operation that doesn't need to return a value of the tree. This is just okay. Okay. Until it knows what is virtual registers, so that's when byte child produced. Okay, so if we have like, if we're using an operation of like a multiplication operation and we have the right and left nodes being 4 and 5 or something like that, the end result will produce 20, which will be an integer value, which needs to be passed back, I assume, to pass to the back end where the actual assembly is being made. So the assembly instruction for multiplication will see that it needs to implement the multiplication instruction based on the values that they put. Based on the values of the node itself, I assume. That's what I'm kind of getting at here. So, okay, I guess, yeah. So I guess it would be a virtual game. But I mean, maybe Cloud might be wrong, and I might just be messing up, but I'll figure it out in the future. The game student's back on, EXO. EXO, if you need help, just let me know. I can help you. I don't have like game development knowledge per se, but I can kind of just help you with anything you need. And I can help you stick to it because, you know, if you're pivoting from idea to idea, I'll kind of like keep you accountable on that. Okay, so visit unary operator. Unary operator, I guess it's also returning an int as well. What's up, Jennifer? Missed my stream? That's okay, that's okay. I'm still gonna stream for a bit longer, so. And I'll probably be streaming tomorrow too. I just needed a bit of time to actually learn what a parser actually does so I don't get too confused. I mean, I still am confused. I still am kind of confused at some points, but it's okay. We'll figure it out. So we need a unary op node reference. That'll be set to 0. Let's just walk through each one. Literal node though. Okay, literal node is where it gets a bit different. So the literal can be an int, it can be a float, it can be any type, really. So what would I do in that case? Would I just what I do is like std variant and make a function specifically for that? Like, is that even possible? Let's see, wait, so that might be totally wrong, but like, okay, let me just include variant up here. Before I leave, I'm just gonna say the name of the game is just like Bee Swarm. That's called Night Swarm instead of bees. We got moss. Hey, let me know if you need help, any help, EXO, with code or like anything, or even just design choices, I guess. You're still here, Ghost? Oh, you'll be here tomorrow. Okay, yeah. I appreciate it, I appreciate it. Yeah, it should be a std variant. So like if you have like std variant, call it int float std string, and we're probably gonna need to declare that. Most likely. Parser takes tokens and returns the st. Yeah, that's what it does. But I'm not actually implementing the parser yet. I'm just setting up the header files for the other stuff first, to actually be able to implement it first. I'm kind of stuck on the visitor pattern though. I guess I didn't study the visitor pattern good enough. Because I thought it would just be void all around the board, but I guess not. I guess it reflects the type that you're returning based on the node. But I guess literal values can also be are you even able to have a function like that? Like, right, so can we do something like, I'm not even sure, to be honest. Like visit literal node, right? I don't even think we can actually do that, so go in order. If you do the parser, you could learn how to do the visitor. Am I able to do that? Like when I was reading the specific book, it said, when I was reading like some documents and stuff, it said to do the visitor pattern, set up the visitor pattern. It's not that I don't understand it, it's just that I don't understand like the total return type thing, because I thought it was void. If I can just understand that part, I can literally get it done. Because I understand how the visitor pattern works, like the implementation of it. Lecture parser AST visitor. Oh, okay. So I guess the parser first, I guess the parser second then. For the example of the literal node. Oh, let me just grab a literal node, right? I see that you can. Yeah, it won't work with the parser, and that's where you actually implement the logic, which I will be doing. Taking any literal type. So I was thinking if I tested variant, but no, it's not for sure. What's up, Lucy? How are you? Have it? Yeah, we said it earlier. Yeah, we said it earlier, yeah. Using literal here. So I guess, I'm just overthinking it, I guess. Wait, so. It's like virtual literal? Wait, okay. Can you even do that? Okay. I guess I was just overthinking it, to be honest. Okay. Parser takes tokens from Lexer, so if you do not have the nodes, why make something that uses the nodes? Yeah. That makes sense, yeah. It's just the way that I saw it, they did visitor pattern, so I thought I should just do a visitor pattern. But I understand what you're saying. Currently learning sockets, C++, because I already have some experience with C. I have seen a couple of videos on YouTube, like some people have been posting like C++ sockets for network programming and stuff. That seems pretty interesting. I hope you have some fun with that. Seems very fun. Okay. I mean, Ghost, I'll probably just finish this visitor pattern because I already understand it now, so I might just finish it up. Okay, identifier node. So the identifier node will take I guess this token itself, right? So identifier node, call it identifier node, reference is n, is equal to 0, and we'll do the rest of them too. Function called node. Function called node. Okay, that's good. That's just gonna be like a vector, right? Essentially. I believe, right? I'm not exactly sure about this one. I'll come back to it. Yeah, so now we need to do the statement one, so we'll call it like statement visitor. I'll probably be ending the stream after the visitor pattern. After I finish it. And then we'll start the parser tomorrow, the actual part of it. So okay, so we want to implement these ones now, the variable declaration statement. So let's first set up destructor for statement visitor. Yo, what's up? I need Rube. Some people are watching this in their sleep. That would be crazy. That would actually be crazy. When I'm done with the shell, I'll make a coding language. Oh, you're making a shell right now? Nice, man, nice. Okay, so statement visitor. Or default destructor. Exo, what are you talking about? How did your computer screen crack? Did you drop it or something? This looks like rocket science. It kind of feels like it right now to me too. But I assure you it's definitely way easier than that. It was fine for this. I kind of went through this pretty well. I don't know, I'm kind of struggling on this for a little bit, but I think we'll figure it out. That's what we have to do. Either way, so let's see. Feel free to join the Discord, guys. It should be the pinned message in the chat right now, if you guys want to. Okay, so variable declaration statement, right? So, I guess it's just the expression itself. You should check this shell out sometime. Yeah, you can send me like your GitHub or something. I can check out the shell. Okay. I need to ask Claude one more time. Okay. So for the next part, we have, what was it, the function call node? And also our statement visitors, but I can't really understand what they exactly return. Would those be void? This is insanely confusing. It seems like that at first, but you just have to kind of learn the fundamentals of it. Even I'm still confused at some points. It's definitely way less abstracted than Python. Python and Lua are like very easy compared to this. But all it takes is a couple months to really start something. Do not know your Discord. You're in my server though, Ghost, right? I'm pretty sure you're in my server. You can just message me there. From the perspective of what the IR generator needs. Okay, so we're gonna need to think from that perspective, right? Is it really like that? Okay, so a function call would be like JAL or JAL-R, those instructions. And yeah, they just return an int, but is it really just that simple, I guess? Like, the statement doesn't produce a value. Yeah, for statement and visitors, I was really confused because void makes the most sense for them. When you're declaring a variable, yeah, you're putting a variable on the stack to be allocated, and yeah, if statement is just a branch instruction, so in assembly it would just be like branch if equal, branch if not equal, stuff like that. Yeah, return statement, yeah, that's like JAL-R, I guess. Yeah. Okay. Okay. So virtual int visit func call node. We want it to be, I think it's func call node exactly. Reference. Okay, so that's good for that. And then for these ones, it will be just virtual void. So like virtual void, I think first one is layer deck. Yeah, it should be pretty simple here now. We actually had a ton of people join the stream. That's actually pretty interesting. And we, oh my god, we got 7 subs today. Nice, that's actually really good. Ret statement, so visit ret. And we'll call it, is it? Red. I don't know why I keep having to come back here. Red statement, yeah. You're a good streamer. Yo, I appreciate it, Ghost. I appreciate it. That's really nice to hear. Visit, I guess, if statement now. So if I really don't know how you got 712 viewers with 100 subs. I don't know either. Should it be higher or should it be lower? I mean, I feel like it should be lower, right? I was checking every day to see if you were live, but I forgot to check today. That's unfortunate. Yeah, I just didn't feel like I was ready the other days. Like, I wanted to stream the other days, but I wasn't ready because I just didn't have enough knowledge on the parser. I mean, I don't know if you guys would like to see, like, my learning process or something. Like, maybe some streams on, like, data structures, lead code streams, stuff like that. I don't know if you guys would be interested, but yeah, I could do those if there's a decent amount of demand for that. Visit while statement. Well, I guess we're not writing a statement here. Yeah, that would be great. Alright, I might do that actually. Just like studying and just talking to chat while I do it. Yeah, I'll be right back, guys. I'm gonna get some water real quick. My water's empty. Alright, we're back. Wait, what was I on? Virtual void block statement, right? Okay. This is just pretty simple. Just keep going until we hit the next part. Are you supposed to spam virtual in C++? You're not spamming it, but like, correct me if I'm wrong, but I believe the virtual keyword just allows essentially like runtime like polymorphism, so you can have multiple implementations of a function, and if you actually call a function, it won't call the direct function, but it'll look during runtime what function specifically suits that. I think I might be oversimplifying it there, but I believe that's what it is from what I've read. Last one is express statement, yeah. Yeah, express statement. Yeah, I think all those are done now. So that's the first part of it. Now we need to actually do the accept functions to actually have the specific implementation it actually points to. So let me first read that in here. Yeah, that's what I'm planning on doing, using the block statement for the body of while and if, etc. WArcs in Discord server. I actually haven't seen who's joined yet in the stream. Okay, yeah, so we just did this part, but now we need to actually implement this part, which will be the accept function. So essentially, it allows us to visit the exact expression that we want. Okay, so our accept always takes the thing that we're visiting as the parameter. So in the case of binary operator, I guess I'll just try to start writing it right now. Like, I guess just a function, we'll call it like binary node. So we're essentially taking that namespace and making a function for that, and the parameter it's gonna be it should be the like the visitor itself, right? So we're calling this function, I think, right? And depending on what it is, it will call the specific implementation. I think, I'm not actually sure, but this is how I kind of would see it being. And we want to the actual implementation of it would be binary operator doesn't remember accept. Yeah, it doesn't. So maybe if we, well, I know in here it's gonna be taking our visitor value, like I believe, like, yeah, it's visit.v.visit. Call it like visit binary op, and then pointer to this. That's how I remember, but I'm not actually sure if that's how the actual thing is. But I believe, all right, no problem. I need Rob. I need Rib. Maybe if you override it. Because we basically want to override this function up here within this, but not exactly sure. Visitor patterns are kind of confusing. Let's see what I'm doing wrong. Let's just read the errors first. Yeah, I know there's not like a no member accept in there. Yeah, what's up, Ghost? What's your question? I'm gonna ask. Doing something wrong here. Yeah, so we need to put it back into the binary node to actually have it. Also, expert self needs to declare accept as a pure virtual so that all derived nodes are forced to implement it. Okay. Are you gonna make a env tool like with Rust and Cargo New? I'm not actually sure, to be honest. It seems out of my scope for now, but maybe. Okay, let's go back to our struct here. Pretty easy and very useful. Interesting. I'll take a look into that. So what exactly, like a void? Okay, so like a void. We need that function to be actually called in here. And it'll be taking that, it'll be taking that visitor. Okay. And overriding. So like just basically defining it beforehand, I believe, right? Yeah, but we also need it up here too. Accept, expert, visitor, and v. How exactly does that go? Like, no, it's not. No, it's just gonna be. How exactly do we actually implement this? Seems like we've hit a roadblock here for the visitor pattern. Maybe I need to do more research about it, to be honest. Hey, we were going pretty strong though, not gonna lie, for the most part. Until we hit the visitor pattern, and then I got really confused. Okay, so it needs to be, oh yeah, it needs to be a virtual so we can actually implement a bunch of different implementations for each function. And why did he set it as 0? I actually don't know why he set it as 0. Let me ask. Why did you as 0? Because I've seen that before. I've seen that many times where they set it as 0, but I don't actually know why. C++ is equals 0 syntax on a virtual function is how you declare it as pure virtual. Okay. All right. Okay. And then once we have that, we can actually implement that everywhere. But let's just start with the first one here. Alright, expected. What does that mean? No, but it has to be in between there. Not override base class member. I mean, did we not set it up here to actually override it, or like, did I do something wrong? Right, so one function declared. Right, base class member. I've never hit that error before, so let me see what it is. Yeah, no, we have that in there properly. And expert visitor must be forward declared for expert references. Alright, it seems like we're just kind of learning C++ language features right now. Circular dependency. Okay, okay. I guess now we know. Now we know that for working with this kind of stuff that we need to have for information. Expert. So now it should work, I guess. Expert visitor, sorry. Or wait, what exactly are we? Okay, so we. All right, so why is this like still a problem? Yeah, it's not in the CPP though. So if we move it here, then no, it will not work. So hey, where exactly did this go? Let's see. Not ht.h, visitor.h. This is where my C++ language knowledge is kind of falling short here, which will get better with time, hopefully. Contain the visitor structs. The accept definition doesn't belong here. That goes in visitor.cpp. So we need a separate visitor.cpp as well, because that's all the implementation for it. Let's see. I just made syntax for coding language I'm gonna make. Nice, nice. What's it gonna be about? It's also like writing once for each one too. I totally forgot about that. And we're still getting the same problem, so I really don't know, to be honest. C++ is so weird sometimes. Do we want to include our parser.h? Not parser, I mean AST. And we're probably going to need something like this one. And we'll do that as we keep going. Fast compiler, not too hard. Do you want to see how to print it? Yeah, sure, I can see that. Yeah, sure. Yeah, defines all accept implementations, but I don't know. It is going on. You don't need that. For .h files, you have to have the function on both sides that line it up. It will not work. Wait, what do you mean by that? There's something I'm missing here, but I'm just not understanding exactly. We're including our visitor, right? So I guess do you mean like in here in the expression visitor function itself, like you implement that in here, like a forward declaration to that? Oh dang, it's 12:30. Yeah, we probably might end the stream soon. It's been 2 hours streaming. I just kind of want to figure this out before I go. Did Klaus say something about that? visitor.h defines x for a visitor and same visitor of all pure virtual methods. I don't remember if he said anything about that here. I guess we're kind of vibe coding right now. Just for this, I'm just trying to figure out what's going wrong. Maybe you could call it vibe coding, or I don't really know what it falls under, to be honest. If we're using it to help, like, fix something. Okay, so I think I kind of understand. So are you saying like actually have that function, like a for declaration or something? Like maybe like that, I guess. I'm not really sure. Yeah, we're gonna have to unscroll that, to be honest. And then with that, we'll probably end the stream. I'll just give it both my visitor CPP and visitor H files. To see what's going on. I need to learn more about C++, like stuff like this, I get really confused. Yes, both sides, yeah. Oh, did I include that here? Oh, my bad. What else? The real error is still the override keyword with the definition. Do we not include override in the CPP? Oh. I thought that's how we would do it, though. Maybe I have to look into that. I really thought that's how you would do that. If we're overriding the implementation of that, that's what I thought was the case from what I studied on OOP, but I guess there's some different case for that. I'm not sure for that, though. Yeah, it looks like we figured, well, it looks like not we, but it looks like Claude figured that out for us. So I should still have the function in the visitor.h, you're saying? Like this. No, do not, my bad. Yeah, it was giving me an error when I did that. Because it's already in here, right? We set up the accept function within binary opnode, and we need to set it up for each following function and define its implementation for each one within here, like that. I just assumed that we might need the override keyword, but I guess I was wrong about that. Yeah, I guess we'll keep learning these little small nuances as we go. With C++. I guess that's what kind of happens when you jump into a huge project a couple months into C++. But yeah, I think that should be the end of today's stream. I think tomorrow we'll finish up the visitor and then start with the parser. So the parser might be more interesting to actually write. Yeah, I appreciate you all for joining. I'll see you all later.